In this video, I'd like to introduce the concept of an arithmetic series. And before we talk about a series, let's remind ourselves what an arithmetic sequence is. So it's a pattern of numbers, sometimes infinite, sometimes not, where when you go from one term to the next, you are adding or subtracting the same number. In this case, we are adding 3 to each of these terms to go from one to the next. And the word we use for that, we call that the common difference. So that's just the number that we are adding or subtracting to go from one term to the next. So the sequence is just the pattern of numbers. But a series, we are actually going to add up every single one of the terms in this sequence. So a series is a sum of numbers from a sequence. So let's write that down. For the series here, we would just add each of these numbers up. So 4 plus 7 plus 10 plus 13 and so on. And this particular sequence ends at 85. So it would be 85, or we can even put the term before that. That's going to be 82 since the common difference is 3, and plus 85. Now, since if we let this sequence go to infinity, we would be adding up an infinite amount of terms that keep getting bigger and bigger, that series would go to infinity, or it would diverge, we would say. So we're going to look at finite arithmetic sequences or finite arithmetic series just so that we can actually add up to some value. And there's a general formula for these that we'll prove in a later video. So let's say you have some general sequence where the first term is A1, then A2, A3, and so on, all the way up to A sub n minus 1 and A sub n, where we don't really need it for the formula, but we can say the common difference between these terms, so the number we add or subtract to go from one term to the next, we can just call that D. And the formula for this, if we actually wanted to add up all these terms, so now we're looking at the series where we have A1 plus A2 plus A3 all the way up to adding A sub n. Basically, we're going to add the first one and the last one, multiply by the total number of terms, and then divide everything by 2. So another way to look at this is that we're going to take the average of the first and the last term here, so A1 plus A sub n, all divided by 2, that's the average, and then multiply it by the number of terms, or add that average n number of times. And like I mentioned, we will prove that in a later video. But for now, let's actually just apply it to this given series here, this sum of a finite number of terms from that arithmetic sequence, where the first term, that's A sub 1, and the last term, that's A sub n. So when we add these, well, first of all, we'd have to figure out how many total terms there are. And since the common difference is 3, you can do that by saying 4 plus 3 added, let's say, an n number of times gave us 85, and then figure out what n would have to be. So we could subtract 4 from each side, you get 3n is 81. Divide everything by 3, you get 27. And so we started with 4 and then have 27 terms after that to get to 85. So there's a total of 28 terms here. So for our case, this n value is actually going to be 28. And if we just plug everything into the formula, we have the 28 total terms multiplied by the average of the first and the last number. So that's 4 plus 85 here, and then divide everything by 2. So you get 14 times 89, which if you put that into a calculator, you get 1,246. So you can actually add up these terms. And a common example problem you see with this is maybe you could say sum the first 100 numbers. So that would be 1 plus 2, plus 3, plus 4, and so on all the way up to 100. And so problems like these are very common arithmetic series. And we'll look at an example like that in a later video.